Now let's go ahead and turn our attention to the demand for labor. So firms and corporations, they find themselves on the demand side for labor because they are the ones that utilize our labor in order to produce goods and services. And the firm's demand for labor is derived from two things. It's derived from number one, demand for its product and the productivity of labor. So exactly how much demand there is for their particular good or services, that's exactly going to tell us how many laborers or workers they need to hire, as well as how efficient and how productive all of the workers are going to be. And we hit on the productivity of labor just a little bit more. So the big question that the firms and corporations have to ask themselves is, how many laborers or workers do I need to hire in my little firm or in my corporation? What is going to be the amount of workers that maximizes my profits? And in order to answer this maximization problem for the firm, we need to go ahead and introduce a few concepts. And the easiest way to go ahead about that is to go ahead and take a look at a story problem. So a little bit of a story problem. So bear with me with this just for a little bit. So demand for labor, demand for labor. And the demand for labor, we need to introduce two particular concepts. So let's go ahead and put yourselves in the story problem right here. So give you a little bit of imagination while we build this information up. So suppose that you own a farm. Suppose you own a farm. Own a farm. You've decided to forsake urban life, go to rural life, and decide to start farming. And you want to see if you want to hire an additional worker. So suppose you own a farm and want to see if you should hire an additional worker. If you should hire an additional worker. So you are the boss and you want to go ahead and see if you should hire an additional worker in your farm. And what exactly do we want to grow on your farm? So use your imagination here. So suppose that you want to hire an additional worker to pick what's the crop that you're going to grow. You can go ahead and say maybe strawberries. Typically, when I say this in class, some people want to get funny and say weed. I can definitely go ahead and go with weed. I've definitely got the right color for this. So strawberries, weed, maybe beets, corn. Doesn't really matter. Whatever crop you want to grow, you want to go ahead and see if you want to hire this additional worker to farm your crops right here. Suppose that this worker can pick, say, 15 strawberries, weed, beets. So whatever crop you have right here, that'd be a pretty good combination of fruits and vegetables right there. So suppose this worker can pick 15 of these crops, and you can sell each one for $10. And you can sell each one for $10. So here, suppose this worker can pick 15 of these crops and you can sell each one for $10. And the question that you should ask yourself, whether or not you want to hire this worker, is what is the maximum wage you should pay this worker? What is the maximum wage you should pay this worker? You should pay this worker. So what do you think is going to be the answer here? What is the lowest wage or the most that you would want to go ahead and pay this worker should you want to hire him or her? The easiest way to go ahead and answer this question is that you hire workers or hire people for what they are worth. So how much does this one worker bring to you in value on your farm? This one worker, if he can pick 15 of these crops and you can sell each one for $10, that means the value he's bringing into your farm is $150, and that is the max wage you should pay this particular worker. So here, in order to answer this question in economics, you simply say you hire people for what they are worth. You hire people for what they are worth, And in this case, this one worker is worth $150 for you. So the max wage you should pay is $150. So $150, and we get that by multiplying the $10 that you get for each of these crops, multiplying it by the amount of crops the worker is able to pick in this instance. And with this, we're going to be able to introduce two concepts, one very, very familiar for us using these particular numbers. The first concept that we need to introduce is something known as the marginal physical product of labor. Marginal physical product of labor. In shorthand, this is just going to be MPPL, marginal physical product of labor. And this tells us exactly what is the additional output that you receive for hiring one additional worker. And if this sounds very familiar to you, it should, because this is just the fancy way of saying what the marginal product was. So if you remember chapter number 7, we talked about the marginal product. When we hire one additional worker, how much additional output do we get? This is the same exact thing. So the marginal physical product of labor is just our idea of marginal product that we saw in chapter number 7. So here, formally, the marginal physical product of labor is the additional output a firm receives for employing an additional unit of labor. For employing an additional unit of labor. An additional unit of labor. So if we hire this one worker, in our case right here, how much additional output is going to be able to generate for our little farm? In order to answer this, we can use a formula. We already know what this formula is. MPPL is equal to the change in quantity divided by the change in labor. So here, we've already tackled this equation before. We're taking some type of differences as we go from 1 worker to 2 workers, 2 workers to 3 workers, and then so on. So the change in Q divided by the change in L. In this instance, this one worker was able to pick 15 strawberries. We only hired one additional worker, so therefore our change in Q is 15. The change in labor is 1. This one worker is able to bring 15 units of this crop. So MPPL, the marginal product, is 15 in this instance. However, we are also interested in seeing the dollar amount that this one worker is going to be able to bring in, and that's where this 150 comes into play. And the special name that we give to that is the marginal revenue product. So here, marginal physical product of labor is just detailing the change in Q over the change in L, while the marginal revenue product of labor, as we sort of call it, just to say that we are in the labor market. So marginal revenue product of labor, we can denote this shorthand MRPL. This tells us how much additional revenue we receive from hiring one more worker. So when we hire this one worker onto our farm, how much in money and dollar amounts is he bringing in value to the firm? So how much additional revenue. So remember, we're taking a look at the marginal or additional amounts right here. The worker earns for a firm. The worker earns for a firm. And once again, there is going to be a formula that is going to be attached to this. MRPL is equal to the marginal revenue times the marginal physical product of labor. So here, the marginal revenue, remember that we are working in a competitive market, the marginal revenue has to equal the price, and the price of the good for these crops right here, we said, was equal to $10. So taking that into mind, $10 times the MPPL, which we just solved out from beforehand. So here, it's equal to $10. Multiply that by the MPPL, which was equal to 15. Therefore, the marginal revenue product of labor is equal to $150. So this one additional worker is going to be able to generate $150 of additional revenue for the farm if we hire him or her. So once again, these two concepts, the marginal physical product of labor and the marginal revenue product of labor, are going to help segue us into seeing exactly what is the optimal amount of workers any firm should be hiring in order to generate the maximum amount of profits. And we'll go ahead and do an example, take a closer look at the table with specific numbers to see the profit maximizing amount of workers to hire in the next video. So here, two major concepts with our little story problem. So hopefully you're imagining yourselves as a little farmer who's growing strawberries, weed, beets, whatever you want to grow in this example.